Hi everyone, once again this is Sir O, your teacher in this session. So if you're new to my classroom, I will really appreciate if you can click the subscribe button and please do include ringing that bell button for you to be notified with my next session. So let us start. In this session, we will try to learn how to evaluate polynomial functions, of course, by the use of what we call as the remainder theorem. So what is the remainder theorem? So in a remainder theorem, if a polynomial function f of x is divided by a binomial x minus c, then the remainder is equal to f of c. So in symbol, of course, when a polynomial f of x or polynomial in x is divided by a binomial x minus c is just equal to f of c, wherein that c is actually the value for x that we are going to evaluate. So for us to appreciate this one, let us have an example. Let us say evaluate f of x is equal to 2x cubed minus 7x squared minus 5x plus 4 when x is 4. So for us to evaluate this polynomial function, of course, copying our given polynomial function, so we will replace the value of x, which is what we asked in the problem, which is f of 4. So we replace x, which is 4. So what we are going to do with this 4 is we will replace all x in the given polynomial function by 4. So let's start with 2x cubed, replacing that one that is 4 cubed, 2 times 4 to the power of 3, and replacing x by 4. So we have negative 7 times 4 squared, and replacing x by 4, that is negative 5 times 4, copy 4. So let us evaluate this further, and we know that 4 to the power of 3 is 4 times 4 is 16, times 4 is 64. So we have 2 times 64. And we know that 4 squared is of course 16, and negative 5 times 4 is 20, copy 4. So 2 times 64 is of course 128, and negative 7 times 16 is of course negative 112, and negative 20 plus 4. If you notice, I already highlighted the terms that are similar. So if they are similar, then we could somehow combine them. So if you notice, I will combine 128 and 4 first because they are of the same sign, as well as negative 112 and negative 20 are of the same sign. So 128 plus 4 is of course 132, and negative 112 minus 20 is of course negative 132. Therefore, our f of 4 is 0. So in other words, we are going to uh, confirm this first, no, because I will be presenting another solution actually. Let us see if they will arrive with the same answer. Of course, what I am talking to is the synthetic division. So in synthetic division, we know that we will be getting only the terms, no, or I mean the coefficients rather of our given polynomial function, which is 2, of course, in our cubic term, 2, and in our quadratic term is negative 7, and in our linear term is negative 5, and our constant term, which is 4. So after identifying the coefficients, we will now have the divisor. So the divisor is actually the value rather of our x, which is 4. So the very first step that we are going to do, by the way, before I will continue, if you are not really mastered or you have not mastered synthetic division, actually there is a link in up here, upper right. You can click this one first and try to study first what is synthetic division. Okay, so again, in synthetic division, the very first step is we will bring down 2. So we have 2 here. And what we are going to do is multiply 4 times 2. That is 8. Of course, we will place 8 below negative 7. And we will add negative 7 plus 8. But since they are unlike sign, so we subtract them. So we have 1. And after that, we will multiply again. 4 times 1 is positive 4. And we will subtract negative 5 plus 4 because they are of unlike sign. So that is also negative 1. 4 times negative 1 is of course negative 4. And 4 minus 4 is of course 0. Now, if you notice, this 0 is our remainder. So we did arrive with the same answer. Therefore, the remainder in synthetic division is just equal to f of c, which is the remainder is 0 in this case, that is equal to f of 4. So in other words, we will arrive with the same answer. Meaning to say, this is the basic concept of the remainder theorem. Your remainder in a synthetic division is just equivalent of f of c, or whatever is the value of our x for that c. So if you have some questions, I will be happy to answer them if you can write your question in the comment section below this video. Example number 2. So we are asked to determine the remainder if in the given polynomial function f of x equals 2x to the power 4 minus 3x squared plus 30 is being divided by x minus 3. So since we know already about synthetic division, so we will apply synthetic division for us to find the remainder. So by synthetic division, we will get only the coefficients of the polynomial function. So let's start with x to the power 4, which is the quartic. So we have 2. And of course, what is next is supposedly is x cubed. But since it is missing, so we will have 0 for that. Then negative 3. And next is the linear term is also missing. So we'll replace that with 0. And of course, the constant term, which is 30. And again, our divisor here is what we are going to do is we equate x minus 3 by 0. And of course, by applying addition property of equality, so x is equal to 3. So our divisor, we will be using 3. So the next step is we will bring down 2. Then we will multiply 3 times 2 is of course 6. And we will place that one below 0. So 0 plus 6 is of course 6. And 3 times 6 is of course 18. And negative 3 plus 18, they are unlike signs, so we subtract them. So that is why it's 15. 3 times 15 is of course 45. And 0 plus 45 is 45. Now, 3 times 45, now since we don't have a calculator, so what we are going to do is 3 times 45, if you notice, I separated 40 and 5 because 40 plus 5 is just 45. So distributing 3 to each term inside this parentheses, so we have 120 plus 15 because 3 times 40 is 120. And 3 times 5 is 15. Adding them, we have 135. Therefore, 3 times 45 is just 135. So 30 plus 135 is of course 165. So our remainder is actually 165. So let us confirm this first by the use of evaluating function. So when we say evaluating function, we will replace x by our divisor, which is 3. So by evaluating function, of course, our x here is of course 3. So the same as our divisor, and replacing x by 3. And evaluating this further, we have f of 3 equals 165. So if you notice, we arrive with the same answer. You are asked for your f of 3 or using synthetic division by the remainder. So actually, you will arrive with the same answer. Example number 3, which is our last example. We are asked to evaluate the polynomial function f of x is equal to x to the power 4 plus x cubed minus 13x squared minus 25x minus 12. And we are looking for f of 2. Now, you can evaluate this function by substituting 2 to each term or replacing x by the value which is 2, or just simply make use of synthetic division. Anyway, by remainder theorem, you will arrive with the same answer with evaluating function. So our divisor is of course 2, and what we are going to do first is we will get the coefficients of the given polynomial function. We have this, and our divisor of course is 2, and we will bring down 1 first, and 2 times 1 is of course 2, and 1 plus 2 is 3. 2 times 3 is of course 6, and negative 13 plus 6 is of course negative 7, and 2 times negative 7 is of course negative 14, and when we add negative 25 plus negative 14 is negative 39. And 2 times negative 39 is, of course, negative 78. And you are going to add them because they are of like sign. So that is negative 90. So negative 90, by the definition of our remainder theorem, our remainder, which is negative 90, is also the value of f of 2, which is negative 90. I hope guys you can give a like to this video tutorial, and please do share this to others for them to learn also what you have done in this session. And please do not forget to subscribe to my channel. That would help me a lot. And please include clicking that notification bell for you to be notified or updated with my next tutorial. Thank you so much.